Imagine quite Harcourt University, Masamba View. Okay, so yes, welcome to Harcourt University once again. If you are new here, you know what to do. Hit on the subscribe button and then turn on notification for new videos. Today I'm going to do something real quick. We're going to solve some questions under mechanism synthesis, which specifically talk about velocity and acceleration analysis. So real quick, let's get into it. We have a quick return mechanism which consists of crank AB and a slider block B and slotted link CD. If the crank has an angular velocity or an angular motion shown, determine the angular motion of the slotted link at the instant. So the slotted link is link CD, right? Good. So at the instant shown, right, we have the AB link position here, AC link position here, and then the crank, which is AB, is rotating with angular velocity 3 rad per second in the counterclockwise direction, and alpha AB also 9 rad per second square in the counterclockwise direction. So we are supposed to find the angular velocity and angular acceleration of the link CD. We know that if we have any 2 points at all in space, and I know the velocity of one, I'm looking for the other. Say I have 2 points that are connected in space AB. Then if I want the velocity of A, I can compare that to B and say VB plus what? Omega AB, which is the angular velocity on the link that connects them, cross R of what? A relative B plus V of A relative B. This term could come first and it's the same thing. All right, so real quick now, we have a point B and A on the same link, and that link is rotating with angular velocity of 3 rad per second. All right, so what you're going to do now is to compare the velocity of B to point what? A, since we know A is a fixed point and the velocity of A is going to be 0. All right, so we are going to compare velocity of A to B. Don't forget, this is a general notation. This is our general relationship, our equation we are going to use. So this time, the point we are looking for each velocity is B. So we are saying that VB is equal to VA plus VB relative A plus angular velocity of AB cross R of what? B relative A. Okay, so what next? VA is 0, VB relative A. This is a sliding relative velocity between A and B. Now between A and B, there is no sliding between them. You can see the AB link is a radial link, so the sliding velocity between A and B is 0. Now the angular velocity is what? 3 rad per second, and this is 2D mechanics, right? So we have a plane mechanics. So with the plane we see is the y-x plane. So if you are rotating within this plane, then you are rotating about the z-axis. So every angular motion will have the z direction. So that will say that our omega AB is equal to 3k rad per second, and then R of B relative A. This is position of B from A. So position of B from A, we have something like this. Here is A, here is B. The length is 100 mm, and then it is inclined at an angle what? 30. All right, so 100, this is a scalar value, so you can put that in vector form. Don't forget we are dealing with vector mechanics. So 100 sine 30, sorry, 100 cos 30. And if you are confused as to whether the horizontal to take the sine or cos, just look at which side of these two makes the angle with the hypotenuse. So here clearly the horizontal makes the angle with the hypotenuse, and that will take the cos. So here will be 100 cos 30, here will be 100 sine what? 30. And obviously we are going to work in meters, right? So the R of B relative is going to be 0.1 cos 0.1 cos 30 I 0.1 cos 30 I plus 0.1 sine 30j. All right, so going to be from here, you move to the right, so move to the top, so it's all positive. All right, so with these parameters known, let's make our substitution. So VB will be equal to 3k cross 0.1 cos 30 I plus 0.1 sine 30 j. So you have to do the cross product. You could use the matrix method, or you can just do the straightforward method. So for me, I use the straight one, and in doing so, you write I, J, K in the counterclockwise direction. So if I want to cross two vectors, let's say I have X, our normal vector product, algebraic product. If I have X, let's say 2x times 3y, you multiply 2 and 3, and then you multiply x and y. So here too, if you are crossing two vectors, 3i cross 4g, you multiply the numbers with the normal multiplication, and then you do the cross on the unit vectors, right? So if you are doing I cross j, so you move I cross j. All right, so the next answer will be the next unit vector. So if you are crossing and then it takes you in this direction, then it is going to be positive. If it gives you this direction, there's going to be negative. So if I have, say, I cross j, that would be what? I cross j. You don't have to skip one unit vector before you get to the j. So if I have k cross j, I don't have to use this side, I have to use this side. So k cross j will be k cross j, and you could see it's going in the opposite of what? The counterclockwise direction. So the answer will be what? Negative I. We're going to have VB to be equal to 3 times 0.1 cos 30, and then k cross what? I. K cross I will be j, right? And then you're going to have plus 3 times 0.1 sine 30, and then k cross j. K cross j will be negative what? Negative I. All right, so let's simplify. 3 times 0.1 sine 30. Okay, so VB, we have 0.259 j minus 0.15 I. Okay, now we can also compare velocity of B to C. All right, so here the B here would have two types of velocity. The B here will be sliding in the slot and then will be rotating at the same time. So when it is rotating, the velocity, the tangential velocity on B when it's rotating is what we have found. All right, so at the instance shown, when B is rotating about C, that velocity will be the same as what we have here. So this velocity here is the velocity of B when it's rotating. It will be the same velocity as B is rotating about point C. All right, so I'm going to compare B to C as well. All right, so I believe now you are familiar with the game. So we are going to compare B to C. So you're going to say velocity of B is equal to velocity of C plus velocity of B relative to C plus angular velocity of BC cross R of B relative C. Okay, so this time c is fixed and 0. The velocity of b relative c is a sliding velocity of b with respect to c, and you could see that because this is a slider, the distance between b and c changes with time, so there's going to be a sliding velocity between them. Now, since we don't know that sliding velocity, we will use a vector. So let's say first of vc equals 0, vb relative c we don't know, so we want to use a vector v to represent that velocity. Now we have to put that velocity in vector form. All right, so that velocity is going to act in this direction, you get it, and in this direction we have the line, which is this line, inclined like this. All right, so as it's inclined like this, you're going to have the velocity in this direction, and then you have it inclined to the vertical axis. All right, so I said earlier here the vertical is making the angle with the hypotenuse, so this becomes what, v cos theta j, then it becomes v sine what, theta I. Okay, so that will mean the, if you factor the v out, they are going to have what, sine 30i plus cos 30j. All right, okay, so what else? The omega bec we don't know, but what we know is that the angular velocity of any angular velocity or angular motion is about the k-axis, as I stated earlier. So omega bc so should be equal to what, let's say omega k. All right, so yes, this is what we don't know. So if we do that substitution, we say vb is equal to 0 plus v into bracket, so sine 30, that's 0.5 I plus root 3 on 2j, and then we have oh, I didn't find the rb relative c. So rb relative c, just as we did rb relative c, so this time to the position of b from c, right? The distance from c to b is 300, which is in the same direction as the velocity, so we have cos 30 sine 30. All right, so this one will be the position, which is 300 into brackets what, sine 30i plus cos 30j. Now we have to deal with meters, so this one becomes 0.3 into bracket sine 30i plus cos 30j. Okay, so with that out of the way, let's keep with our substitution. So we have done substitution for this, we have done for this, left with this, so plus omega k cross 0.3 sine 30i plus 0.3 cos 30j. Okay, so real quick, let's simplify this and see what we have. So vb is equal to, so we have v 0.5 vi, and then plus v on 2 root 3g, and then here we are going to have 0.3 sine, that's 0.15, right? So plus 0.15, and then k cross I, so we come back, k cross I is positive j, so put j here, and then we will have cos 0.3 cos 30, 0.2598, so we have plus 0.2598. oh, I didn't bring the omega here, so we are multiplying omega k, or we are crossing omega k to this, so this alone will give us 0.15, so you show the magnitude omega there, so that would be omega or 0.15 omega g. All right, and this will be 0.598 omega into brackets negative I. K cross J is negative I. You can do what I've been doing all this while. So at this point, we'll group the I's and we'll group the J. So VB is equal to 0.5 V minus 0.2598 omega I, and then plus V on 2 root 3 plus 0.15 omega G. All right, so since this VB and this VB are the same, we can say that 0.2598 G minus 0.15 I is equal to 0.5 V minus 0.2598 omega I plus V on 2 root 3 plus 0.15 omega G. Okay, so from here we can say that the J on the left is equal to the J on the right. The I on the left is equal to the I on the right. So negative 0.15 is equal to 0.5 V minus 0.2598 omega, and then 0.2598 because it's equal to V out of 2 root 3 plus 0.15 omega. All right, so from here you don't need to worry yourself with any substitution, whatever method. Just give it your calculator to do. So we are going to use V as our X and then omega as our Y. Okay, so coefficients of x 0.5 minus 0.2598, the negative 0.15, and then we have root 3 root 3 on 2 0.15 and then 0.2598. All right, so we have V to be equal to 0.1499 meter per second and omega to be 0.866 rad per second. Okay, so the sliding velocity of B with respect to C is equal to 0.1499 meter per second, and then the angular velocity of length BC is equal to 0.866 rad per second. So this is the velocity, the angular velocity of the length BC. What is left is to find the angular acceleration. All right, so I'm going to follow the same procedure. Okay, so for the angular acceleration, just as we had earlier with 2 points A, B, if I want to find acceleration of A comparing to B, acceleration of A will be equal to acceleration of B plus acceleration of A with respect to B plus angular acceleration cross R of A with respect to B plus 2 times the angular velocity of AB cross velocity of A with respect to B plus minus omega EB squared R of A with respect to what B. So this time, yeah, just as we did for the velocity, I'm going to compare B to what A. So acceleration of B is equal to acceleration of what A plus, because I'm comparing B to A. Don't forget here, this is a general term when we are comparing A to B. So acceleration of B will be equal to acceleration of A plus acceleration of B with respect to what A. That is the relative acceleration in the relative acceleration due to translation. Okay, now the next is the alpha AB cross R of B from A plus 2 times omega AB cross R of B from A, or with respect to A, and no, that's supposed to be V, right? V of A with respect to B, V of B with respect to A minus omega AB squared R of B with respect to A. Now, the acceleration of A, since the velocity of A is 0, acceleration of A is also 0. There's no sliding velocity between them, so this is also 0. What else? There's no velocity, sliding velocity between them. This is what 0. So we can say that acceleration of B is equal to alpha AB cross R of A with respect to B minus omega squared R of B with respect to A. Oh, why do I keep repeating this thing? R of B with respect to A. All right, so from here, what do we have? Alpha is giving us 9 rad per second square, and this is K, of course. Now our R of B with respect to A, that is what we did here. So let's go back to the previous page. R of B with respect to A, where's that guy? R of B with respect to A, yes, here it is. So 0.1 cos 30i, 0.1 sine 30i. So real quick, our alpha is 9k. R of B with respect to A, we have 0.1 sine 30j plus 0.1 cos 30i. You can bring either one first, right? And then the angular velocity AB, that is what we know to be 3k. And yes, we know this already. So real quick, we can find the velocity acceleration of B to be equal to 9k cross R of B with respect to A, have 0.1 cos 30i plus 0.1 sine 30j, and then minus omega squared, which is 3 squared, right? So that's, if you have the formula like this, you don't, the omega here, you ignore the k. So here is a scalar product, not a cross product. If it was to be cross, I will bring the cross sign, and then I will bring a full lecture that explains this equation in a bit. That is to say, if you've watched up to this point, kindly subscribe and like the video to show your support. Now let's move on. So here 3 squared, we don't add the direction, all right, it has already been done in there. So here the R of B relative area 0.1 sine 30j plus 0.1 cos 30i. All right, so this one too, you see I'm changing them is because I just forget and write the sign first, you understand? So it doesn't change anything. I don't want to clean and clean. So let's go real quick. So AB will be equal to, so you multiply the scalars, you cross the vectors, 9 times 0.1 cos 30, and then q cross I. So our I, J, K cross I will be what? J. So you put J here. And then we also have what? Plus 9 times 0.1 sine 30. Now K cross J goes against the direction. So negative I. Alright, now over here we don't have to do any cross, so it's going to be minus 9 times 0.1 sine 30 J and then minus 9 times 0.1 cos 30 I. Okay, so let's simplify. Let's simplify our terms. So first off, we have 9 times 0.1 cos 30. So this gives us 0.7794 G, and then we have 0.9 sine 30. So this gives us 0.4. Oh, that will be minus, right? Minus 0.45 I, and then I think that will just repeat, right? So this one will be minus 0. The cos was this, so minus 0.7794 I minus 0.45 G. All right. So this, and this is this. This is this. So the signs will have this. The J is sign. The J, the I is sign here. Okay. All right. Of course, it's this. Of course, this guy. All right. So AB is equal to this. So from here we can group we can just put them together. So we have 0.7794 G minus 0.45 G. So 0.7794 minus 0.45. So AB is equal to 0.3294 G, and then we have minus 0. So that would be minus 0.45 I So we have minus 1.2294 I. All right. So that is the acceleration of B. So you're going to follow the same method as we did for the velocity. You're going to find the velocity, the acceleration of B with respect to C this time, and see what we can come with. So this time acceleration of B will be equal to acceleration of C plus angular acceleration of B with respect to C plus the angular acceleration of BC cross R of B with respect to C plus 2 angular velocity of BC cross B of B with respect to C minus omega squared r. This is omega b c. All right, so first off, c is a fixed point, the velocity is 0. The acceleration of b with respect to c we don't know. All right, the acceleration of b with respect to c we don't know, so that's just as the velocity. So here the velocity of b with respect to c we didn't know, and it was in this vector form. So this time acceleration, you just have acceleration here. You can use a to represent acceleration. Then you have sine theta I cos theta j. All right, if you've forgotten how we came up with this, just go back and watch how we did this. And then what else? Yes, that's that. So acceleration of b with respect to c will be equal to a magnitude a and then sine 30i plus cos 30j. What else? Alpha b c, that's we don't know, right? So but we know it's going to be what? Alpha k, because it's also going to rotate about the z-axis. The r of b with respect to c, yeah, that's what we had. We don't have that yet, but just as we did for the velocity, r of b with respect to c, r of b with respect to c, where is that guy? Here is it. 0.3 sine 30i plus cos 30j. So r of b with respect to c, 0.3 sine 30i plus cos 30j. All right, now next, the omega bc. Omega bc, we had in our previous example, we had omega bc to be 0.866. So we have 0.866 k, and then vb relative c, that we had previous, we had 0.1499 meter per second. So that would be 0.1499. So that's in vector form will be what? So we made this assumption earlier that we are going to say the velocity of b with respect to c, the sliding velocity is going to be this, right? So the magnitude sine 30i cos 30j. So sine 30i plus cos 30j. So we know everything here. All right, so acceleration b is equal to 0 plus acceleration of b with respect to c, a into bracket 0.5 I plus root 3 on 2j, and then so this is the substitution I'm making. Then the next is plus alpha, which you don't know, so you say alpha k cross r of b relative c, so 0.3 sine 30i plus 0.3 cos 30j, and then we have plus 2 omega bc, have 0.866 k cross, and the velocity we have 0.1499 into bracket sine 30i plus cos 30j, and then the last term minus 0.866 squared multiplying 0.3 sine 30i plus 0.3 cos 30j. Okay, so let's simplify. So AB will be equal to, so yeah, you're going to get 0.5 AI plus root 3 on 2, what that is, root 3 0.866 0.866 J, then plus, so this time 0.3 sine 0.3 sine 30, that's 0.15, right? So 0.15 alpha, and then k cross I will be what? J, right? And then the next one we have 0.3 times 0.866, so we have 0.2598, so plus 0.2598 E, and then K cross J is negative I, so we have negative I here. Okay, next we are done with this guy. We come to what is here. So this time you have to first expand this. All right, so you're going to have 2 times 0.866K cross 0.149 sine 30I. So I'm going to have something like this. So plus 2 into bracket 0.866 times 0.1499 sine 30, and then in the direction. All right, so which is what? K cross I. K cross I is J. K cross I is J. Now this level, if you understand, you can just do the direct multiplication. I'm doing this to avoid any confusion. So I have now the next, I will cross this to the J. So 2 times this, which is plus 2 times 0.866 times 0.1499 cos 30, and then the direction I have what? K cross J. K cross J is going to be negative I. All right, so we just punch them, and then we come to this guy, the last one here. We have minus 0.86 squared times this and times that, so that will be minus 0.866 squared times 0.3 sine 30 I minus 0.866 squared which bracket 0.3 cos 30 G. Okay, so that would mean AB is equal to 0.59 0.5 AI plus 0.866 G, sorry, E. So the A didn't come up here. Supposed to get A here because we are using this to expand this. So 0.866 AG, and then plus 0.15 alpha G plus 0.2598. So here we have negative I. So let me introduce that before we forget to use that. Okay, so we have negative here, and then our I comes the I alpha, right? Alpha I, yeah, which is this. Oh, I made it in supposed to be alpha. All right, then the next we simplify that. So 2 2 times 0.8 0.866 times 0.1499 sine 30. That's a 0.1298. So I'm going to have plus 0.1298j, and then this one is negative, so the same thing but just cos here. Cos 30. 0.2248. So minus 0.2248i, and then the last class here. Zero 0.866 squared sine 30. Zero 0.3749 or 0.375. So we have minus 0.375 I, and then minus cos 30. 0.649. We have 0.649, let's say 5j. All right, so at this point we can group the I values and the j values. Let's go. So a, b, we have 0.5 ai, and no, let's ignore the I first. So I'm grouping all the I values. So I here, this one is not I, this is j, this is j, this is I. So negative 0.2598 alpha. Let's ignore the I for now. Alpha, and then what's you have negative 0.2248 I. Sorry, so all in brackets I here, and then the j we have, let's bring plus, so we have 0.866 e, and then plus 0.15 alpha. So this is gone, this is gone, and then oh wait. So AB, we have 0.5 AI. So I'm grouping the I's and the J's. So AB will be 0.5 AI. Oh, come on. 0.5 E. The next I is minus 0.2598 alpha. The next I minus 0.2248. The next I minus 0.375. Okay, so all in I, plus then the J we have 0.866 E, the next G plus 0.15 alpha, the next G plus 0.1298, the next G minus 0.6495 G. Okay, so at this point, just as we did for the first one, the B here is equal to what? The AB here. So the I value there, the I term here is equal to the and all of that. So let's equate them. So this, which is 0.3294, 0.3294, I think J, minus 1.2294, 1.2. Let's take it again. All right. 1.2294 I is equal to 0.5 A minus 0.2598 alpha minus 0.2248 minus 0.375 I plus 0.866 A plus 0.15 alpha plus 0.1298 minus 0.6495 J. All right, so with this understood, whatever J is says to J is equal to the J term here, whatever I is equal to the I term here. So you're going to say negative 1.2294 is equal to 0.5 A minus 0.2598 alpha minus 0.2248 minus 0.375, equation 1. And then the J, 0.3294 is equal to 0.866 A plus 0.15 alpha plus 0.1298 minus 0.6495, equation 2. All right, so let's just put the numbers together and then use your calculator. So this plus this will be negative comes here. So we have negative 1.2294 plus 0.2248 and then 0.375. So that would mean negative 0.6266 is equal to 0.5 A minus 0.2598 alpha, equation 1. Then we deal with this guy. So we have 0.3294 plus 0.6495 minus 0.1298. All right, so we have 0.8491 is equal to 0.866 A plus 0.15 alpha, equation 2. So yes, we give Visual Calculator to do this for us. All right, so we are making A as X and alpha as Y. So we have 0.5. We have negative 0.2598 alpha, and that is equal to negative 0.6266, and then we have 0.866, the next is negative positive 0.15 is equal to 0.8491. Okay, so we have E to be equal to 0.562 and alpha (2.4119). All right, so A will be equal to 0.5, which is A of B relative C, 0.52 meter per second, and alpha BC will be 2.4119 rad per second squared. So this is the end of the problem 1. I'm going to follow the same procedure for the next problems. Now, if you've watched up to this point and it has helped you or you've understood, kindly subscribe if you haven't, and kindly like the video to let me know you enjoyed it. And also, if you have a question, let me know in the comment section and I will attend to you as early as possible. Thank you.